This afternoon, we're going to talk about NAT, then we're going to do SNMP and some other monitoring systems in the second lesson today. NAT, and it does several things. One, a security mechanism. It protects our internal network structure so that somebody can't see how many or what addresses we have. We're going to have three types of NAT, and I want to work through each of them actually on the static NAT. I'm going to show you on the PAT, the port address translation, and the dynamic NAT. I want to go through a config, but it conceals the internal addressing scheme, hence a security mechanism. It also, and this is me, was a way to extend the IPv4 address space. We're out of addresses. We've been out of addresses for about a year, but because we have all of these private IP networks, private networks inside of our public inside of our corporate networks, like back here, the 192s, like at your house and my house, 192.168.1.0 network, which is Class C private, that we have a NAT service that translates that address to a public address. If we have a lot of public IP addresses, we can do a one-to-one translation. So the 192.168 might go to a 200, and then we have a .1 address, and the .2 address might go to a 200. We'll do .1 and .2 and on down the line. If I only have a single IP address, then it would go to the 72 whatever it is and a port number, and would be translated to my 192.168.1.27 port number. By using different port numbers, and we've talked about socket, and the socket makes it unique, so we can use the port address translation function of NAT to use a single IP address to NAT, PAT, port address to multiple private IP. Enables a host using a private IP address in a local network to communicate on the internet. The NAT service running on the router translates the private address to a globally unique public IP address or a globally unique socket if we only have a single interface, a single address, the interface address. And that's what you and I use at home, or at least that's what I use at home. I'm presuming that's what you use at home too, unless you have bought multiple public IP addresses. We're going to be using the port address translation function of the network address translation service. Packets sent to the internet from the internal host appear as if they came from a public address. Other advantage to PAT is they look like they all came from the same address. Same thing with proxy servers. They all look like they come from the same address. So that goes us one better. If we use a NAT with a pool of addresses and the pool of the number of public addresses that we have, then we might get into a situation somebody can estimate how many we have at the other end, but they don't know the structure that we're using internally. So preventing external hosts from connecting to the internal host. And when you do that, we have the public address that goes out there, so they follow the public address back to the firewall, which is typically going to be the NAT device. And it's like, okay, now what do I do? I don't have any idea what address I'm trying to get into. So it does serve as a security device as well as, I guess, an obfuscation device of how many different things that we have. What we have here is, it starts with static NAT. What I want to do, and then we'll go through the slides, is look at NATing. Cisco has some, I think, kind of different terms used in NAT. If you go to a Windows server and set up routing remote access and NAT, you check the NAT and yep, it NATs for you. You can put in public addresses, or you can, if you leave it alone, it's PAT. So in this case, we have some terminology that you need to know because it's used in the configuration. We have the inside local here. The inside local is my private addresses. And then we have the inside global, and this is my public addresses. And they define outside global and outside local. These are the other guys. We don't have anything to do with that. The only thing we know is that, yep, we got to the outside global. Have no clue what their outside local is. Their private IP. So private IPs are the inside and the public IPs are the outside when we do the configurations on these things. The reason I say that, we're going to NAT inside to do these things. So we have the inside, the outside in order to run the Cisco NAT. I've got my cheat sheet, and I always admit that I got my cheat sheet because I am far from perfect on these things. So opening this thing, and the steps over here for PAT, port address translation, label the interfaces. We have to specify which is the inside interface and which is the outside interface. Then we create an access control list. Did access control list this morning. We're going to use them this afternoon. Which of the addresses inside my private network can be NATed? We don't have to NAT everybody. We can NAT certain ranges of addresses. And then we'll enable NAT with the IPNAT command. So kind of 3 steps, and over here the dynamic NAT. The other thing is the thing that's going to be added here is we have to add an address pool. So be sure this isn't working yet. And I always get these. I don't know why I use it. I know why I use these addresses because I got the infrastructure from somebody else. So 117 will go from back here. 117.45.23.1. If I try to ping that, ping 117 dot. Let's go step by step. Let's go. We'll presume we can do the gateway. Let's do 117.45.23.2. 117.45.23.2. And that one should work because that's on my side of the router. But when I try to go beyond it, I can't get anywhere. 117 is timed out, and it's going to time out, time out, time out. At least I hope it's going to time out, time out, time out, because NAT should not be configured on this device yet. So we can get to our router, but we can't get any further than that. We need to be able to do that, and the routing all takes place on the public IP addresses, because remember, we can't route a private IP address. In that, in order to do these configurations, config T, and we have, well, I guess we get to enable, and config T would work better, huh? Config T, we've got an inside and an outside interface, and when I look at this thing, 01 is the outside and 00 is the inside. Just as an kind of a helper little thing, this is backwards to what you really probably would want to do, because if we use 0 for the outside, the 0 looks like an O for outside. And if we use a 1 for the inside, a 1 kind of looks like an I for inside. But I've got mine backwards, so we'll just live with that one. So we can go to interface, Fast Ethernet 01, and it's then going to be IP. And when we do the commands here, what we can see here, IP access group, address, authentication flow, inspect. And then we have NAT here. So if NAT, and then the help, NAT inside or outside. And this is going to be, this is 0, so it's going to be the inside, all right? And then we go to interface Fast Ethernet 01, IP NAT outside. The next thing that we need is an access control list to specify which of the IP addresses we'll be able to NAT. So the IP addresses that we're going to be able to NAT is going to be the 192.168.1 network. So we'll do access. I guess if I config, it would be better, wouldn't it? Config T, access, and that's the tipper when the tab key works. So you do the tab, nothing happens. Like, okay, what have I done wrong here? And sometimes I say, I'm right. I'm going to keep going here. But access list 1, since we're only going to do source IP addresses, we might as well use this. We're only going to have one statement in here. Permit 192.168.1.0. And now we're going to do the wildcard mask. We're going to check to see if it's 192. To check to see if it's 168. To check to see if it's 1. And then anything on that network, the 255, is going to be allowed to get a translation that goes on. And then the first one we're going to do is the PAT, the port address translation, and then we'll take it off and put in an address pool and do the dynamic NAT. So now we need to go to the config, and we'll do IP NAT, and we're going to NAT inside, and that's why we had to label the interfaces inside or outside. We're going to NAT the inside, and then we'll go ahead and look at, let's go back and look at what you would see, IP NAT, we know we're going to do that. And then the question mark, inside or outside. We're going to go where we're going to NAT from inside out or outside in, and the pool defines a pool of addresses if we have that. So IP NAT, and we're going to NAT the inside to the outside. The only thing we have to tell it is what we're going to NAT. And after that, what? The source. And the source can either be a static NAT, or a list. And the list is the access control list that we created. Access list 1. It's going to be interface fast Ethernet 0/1 or outside. And in order to make it port address translation, we have to give the modifier overload. Even if you do a dynamic NAT, you probably want to use overload. Overload says, hey, use ports to do the translation for these things. And the dynamic NAT, if you run out of public addresses to NAT to and you use the overload command after it, it'll then go into port address or PAT mode. So now then, let's see if we can get to the other guy. It's easier if since I will not make maybe such a big mess, let's try it here. And the waiting always kills me on these things. Did I do it right? Timed out. And sometimes this one does take a little while. And I may have messed it up. Sometimes it takes more than a little while. And sometimes I didn't get it right. Now let's try it again. 23.1 is where we're trying to go. So then we got to go back and look and see what I did wrong. No, that switch doesn't have an IP address on it, Mike. Oh, this one? This I just stuck in here. It's the IPNet inside source list 1 interface fast Ethernet 0/1 overload. And I did the, let's be sure that I've got the interfaces done right. IP address. Here's the problem. Fast Ethernet, my IP NAT inside didn't take, so it's trying to NAT something that doesn't exist. So let's try this one again. I thought I did that. Maybe I did that wrong. Config T interface fast Ethernet 0/1 IP NAT inside. Now let's do a show run, and this is where the show commands, when you talk about troubleshooting, the show commands really stand up. Now, I did the wrong one, so what we're going to do is config T interface fast Ethernet 0/1 no IP NAT inside, and it's going to be an IP NAT outside. And the interface fast Ethernet 0/0, I think that I put the label on the same interface twice. IP NAT inside. Now let's see if we have anything. Show run. 192 IP NAT inside, so 1.1 is the inside interface and the 117 is the outside interface. Now let's see if it works any better. Hopefully it will when we do those things. Yeah. Oh, we're back in business now. When you get the configuration right, it usually works a lot better. So I finally got there. What we can do is C, show IP NAT translations, will show us the translations. You notice we have the address, the inside global address, and the inside local address. The inside local, again, local, inside is us, and outside is them. So inside the local are 192.168, our public address on our router 117.45.23.2. You notice over here that both of them is the public address. We don't have a clue what's on the inside of that, so we can't really designate one to the other. Let's see if we can, I'm going to try to not do my typos. So we'll copy here and do a no, and it probably won't let me do this because we have, well, it did. You frequently it won't because they're translations, and you can clear the IP NAT translations, but you have to use the asterisk to do all of these things. So now then, do show run. We have the interfaces labeled. I'm not going to take them off and put them back on. Same thing for each one. The access control list, we're going to use the same thing. I'm just going to do that which is necessary in order to do the dynamic NAT. So we have the access list and we have them labeled. So what we're going to do here now is IP NAT pool, and let's call it public addresses public. Let's call it public. And then after that it says what's the starting address. Let's use 117.45.23. Well, let's go to 5. And then after that is what is the end address. 117.45.23.10. I don't need a whole lot here because I only have two workstations. And then the net mask. This is the one that you'd think that, yeah, I'm just going to type the subnet mask, but you have to type the word net mask 255.255.255.0 for these things. Now then, the next thing that I'm going to do is IP NAT, again, IP NAT, and then we're going to IP NAT inside because we're natting the inside interface. IP NAT inside, and then we have our source again. And this case we've got the list, the source, the list, which is the access control list, list 1, and after that pool, the name of the pool. So pool, and then what did I call the pool? I've forgotten already. IP NAT public. Pool was public. Public. And I'm going to give the overload command, although I don't need it, but what that does is if I used up all of my pool addresses, it would go from a one-to-one natting to a port address translation. Now then, you're going to try the magic. Try to see if it still runs here. So 23.1, and this is always a scary whenever it doesn't. Okay, good. It worked that time. It just had to get going. So if I go in here and do the get out of here. These don't stay in very long. Show IP NAT translations. Then we have the 5 address, which was the first one that we did, is translated a one-to-one, an IP, a private IP to a public IT, inside global, inside local, a local to a global address. And then we go to the other end. We don't really care about that. They still have to have ports because we have to have sockets to have connections to actually get it to a service or get it to a location. The static NAT, and I have, I think, one on this one that we can just look at. Show run. And the IP NAT inside source static TCP 192.168.2.2 port 80, I'm NATing the web server to 23.1. So if this one works, I should be able to go to 117, go to my, get out of here and go to my little web server, go to HTTP 117.45.23.1, and let's see if that works. So we've got a NAT. We NATed from outside in, and we've NATed from, or inside out, and we've also NATed from outside in at the other end with the static NAT. Static NAT is exactly what's going on here, what you would use it for. When you want to have a resource inside your private IP address, but be able to access it through a public address. The other way to make that work is a reverse proxy, so that those at the and if you use that, the other people wouldn't actually be able to get onto your network. In this case, we're going to have users from outside of the protected network, our private network, from the untrusted internet network, to be able to actually get into the devices on our private network. You may or may not want to do that, but you can do it with a static NAT from outside in. You could also do it from inside out, but that'd be a lot of addresses. I mean, if you had somebody that always needed to be the same IP address, you could go that way. But in this case, we NATed the address and the port number, port 80, to get it to port 80 on the private network. And you guys have probably done port forwarding on your routers to do things occasionally that you may want to do with them. So with that, we'll look at the slides here. Static NAT, in which each private address used in the local network is mapped to a specific registered public IP address. The static that we saw, we did the 23.1 address to the 2.2 address on it. The IP address of the host within a local network is always translated to the same public address, and we can do a static from inside out or outside in. The NAT router maintains a static one-to-one mapping. Private IP addresses used by a host within a local network is also called the inside local address, and that's why the term here, the terms here, and I think that, you know, the inside local is our private. The inside global, we're the inside network. The inside global is our publics. The outside global is somebody outside of our network, and then the outside local. So the terminology, yeah, and we use it in the NAT statement also. Private addresses used by the host are called the inside local. The public addresses the inside global. So the static is a one-to-one translation. The dynamic, we have an address pool, which each private address used in the local network is mapped to a registered public IP address dynamically. Advantage here is you only get to use that address as long as you have a connection. When you're done, when your connection's over, your session's over, you give the address back to the pool so that somebody else can use it. Advantage here, you don't need as many public addresses as you have private addresses. So you can use a much smaller range of addresses if you need to do that. An address pool with the available public addresses is there. The router is configured with a matching logic for the address translation. Also maintains a NAT table. That's when we looked at the show IP NAT translations to do those things. Packet reaches the router from the internal host, applies the matching logic. Am I permitted to do this by the access control list that I had to create? Which addresses can get NATed can be NATed. Adds an entry to the NAT table showing the inside global address. Saw that in the show IP NAT translations. And then it performs the translation and routes the packet to the external network. When it comes back from that address, goes through the NAT table, obviously, and then sends the information back to the private address. PAT Port address translation. Same basic process as the dynamic NAT, except we're only going to use the single address. A subset of dynamic NAT maps a private address dynamically to the public IP address, also called dynamic NAT overloading. And that's what the overload modifier is after the NAT statement, that yes, we're going to overload the IP address. We're going to go into port address translation. We're going to use ports instead of IP addresses. And again, it's always a good idea to do that even when you use the dynamic NAT, just in case you run out of addresses. Everybody decided to go on the internet at the same time for whatever reason. A router configured with PAT maintains a dynamic table that lists port numbers of the inside local and the inside global addresses. So we're using the same IP addresses, but by using unique ports, we are, for the source address, we're creating unique sockets. And the socket, the IP address, and the port number makes it unique. Whether we have the same IP address and a whole lot of different port numbers, still becomes unique so that we can connect to it. We have lots of different sockets, connection points for these things. Port number, the inside local, for every inside local address added to the table, dynamically NATs an inside global address along with a unique port number to do those things. And we have a whole lot more port numbers than we have IP addresses. And all of us do, because how many, and you think about it at home, you have probably, you bought one IP address like just about everybody else in the world, but how many devices do you have inside of your network? You probably got a computer, maybe a tablet or two, phone, television, streaming, maybe a laptop. All of those devices have to be able to have unique identities in order to get from one to the other. Otherwise, you just get back a jumble, and you'll be watching somebody else's movie or something when you do those things. So the port address translation creates unique sockets, unique connections for those things. So it maps multiple addresses, the inside local, the private IPs, to a single outside global, a single public address. IP NAT pool. The NAT pool is the public addresses used by the NAT for dynamic mapping. These are addresses that we have to own. And you also think that, and we also have to have routing back to these things, because if we just throw on some public addresses and the routers don't know how to get it back to that range, it doesn't do us any good. So we have to have the public addresses, and we also have to have routing information that goes to those things. First step, dynamic route, includes configuration of the interfaces involved. We label them inside and outside. Finally, the interfaces and configuration of the access control list to filter the inside local addresses that require NAT. Which addresses, the access control list, which addresses are allowed to get a NATed address. The final step in the dynamic, the pool, the source list. We're going to do the IP NAT pool, the pool of addresses that we're going to use, and then the command that we use, IP NAT inside source list command, and then we used the pool. We could either use the interface and the overload, or we could use the pool name for the addresses that we used with it. Many-to-one, PAT overloads NAT to enable many-to-one mapping of IP addresses. The one IP address, the public address, the many are the privates that we have. IP NAT inside, IP NAT outside, in order to label the interfaces as inside and outside interfaces. Set up the access control list, who can do it, and then IP NAT inside, source list, whatever the ACL number is, the interface ID, the interface type and number, interface fast Ethernet, and the number 01, and then overload. Overload says, hey, overload the address, I guess is a good way to think of that. And we're going to go into port address translation. Overload option indicates that PAT is used to translate the IP address to the address of the interface when we do those things. So we have now Another lab set today is a lot of lab and a little bit of lecture.